This is Shakil Ahmed. In this tutorial, we will discuss about correlation analysis. Correlation analysis is mostly conducted at the start of the regression or exploratory data analysis, where we want to see the relationship between different continuous variables. Correlation coefficient basically measures the linear relationship between quantitative variables in terms of sign as well as in terms of magnitude, strength. Basically, it tells the direction of the correlation as well as the strength of the correlation. So we will discuss the most widely used correlation measures, uh, which is the Pearson correlation and the alternative Spearman correlation, that is a non-parametric version when we have data, then we use the ranks of the data instead of the original data set. That is called the Spearman version of the correlation. And we also discuss the Kendall's Tau, that is uh, also tells the association between strength of relationship between the two variables. So we have the spokes data where we see the continuous variable on as age, BMI, and average glucose level. These are the continuous variables. So we start with the assumptions. The variables should be continuous and the variables should be approximately normal distributed if there is the data relation. And there is a linear relationship between the variables. It only says the linear relationship between the variables. If there is a non-linear relationship, then we can't capture through correlation. So we have a BMI, and we just take three variables: age, BMI, and average glucose level, and we just first check is there any missing value, uh, any variable. There is a missing. There are some missing value in BMI. So we just check and then replace the missing values by their mean. In our first lecture, how to replace the missing values. And after imputing the missing values, we have three variables. We have a data frame consist of age, BMI, and glucose. This is the data frame, and the variables are extracted. If your data consists of all continuous variable, then you can just take your data frame. You don't need to mention the variables. And then correlation, and the method is Pearson. And if you are using Spearman, then just write method is Spearman. And then you are printing the correlation matrix. So just run this, you can see the correlation matrix between the three variables. This is the correlation between BMI and age, and this is the correlation between average glucose and BMI. And if you want to convert this table more into more interactive table, then click here. You can just copy this and paste on your Word file. You can visualize the correlation as we have already discussed. You can uh, import the Seaborn as SNS and then Matplotlib library as PLT. And then you can set the figure size if you want to increase the figure size. If you want, for example, I want to increase this width of the figure. This is as add. And then SNS Heatmap. Heatmap basically we can use to see the correlation. If the strength is high, then it will give the red color, and if the strength is low, then it is giving the blue color. So this is the positive, and then the frequencies we are reporting up to 2 decimal places. If you want to report up to 4 decimal places, you can just write it. and line width is 0.5. You can increase it, and then you can give the title of plot, and you can show plot is a consist of a title, and the values are now the lines are more uh, and we are reporting up to 4 decimal places. So here we have three variables, and we have three variables, and we can see the correlations, and the correlation is more and stronger correlation is in more uh, darker red. The Spearman correlation is basically we use the rank values instead of original values, and uh, relax in the assumption that the variable should be now at least on ordinal scale, not on continuous, so restricted to the ratio scale. Now we are giving some relaxation. And the relationship between the variable does not need to be linear in this case, and the normality assumption is also relaxed in Spearman correlation. So we again uh, plot library to make the plot. Although you can also use the heat map using SNS command, and then Spearman correlation matrix. That is again just we use the same command and the method to Spearman, and then you can print correlation matrix and Spearman correlation matrix, and then again. So the interpretation is almost same, but simple. The difference is here we are using the rank of the data, not the original data. And this Kendall star test. Kendall star test is used to assess the monotonic relationship between two ordinal variables. It measures the similarity in their ranking. Basically, ranks are going in same direction or in different direction. Unlike Pearson correlation, Kendall star does not assume the linear relationship and is more robust to outlier. If you have outliers in your data, that can be captured through uh, Kendall star test and Kendall star correlation. So here are three assumptions, and again we are importing PLT from it. And then we again using the same variables BMI, age, and glucose, and we imputed the missing BMI, and then print the Kendall stock correlation, and you can see map. Finally, you can in certain cases you need to report the p-values of the correlation. So although you can match within these boxes, I have just taken a simple example of two variables using Pearson correlation. For that, we need to import sci-pi states, and then from Pearson R, and using Pearson R to these two variables, age and glucose, we computed the correlation and the p-value, and then I reported the correlation up to 3 decimal places and the p-value up to 4 decimal places, and you can just run it. Some correlation is 0.23 between age and average glucose level, and it is statistically significant. So that's all about the correlation analysis you need to do. You can with these in the table, but the commands become somehow complex. That's why I'm not mentioning here. So if you have any question, please always write in comment section. Thank you.